Hello everyone, welcome to channel. Today we are gonna talk about how can we avoid race conditions with mutexes. First, let's define what is race condition. First of all, race condition is basically if you have more than one threads and if you have a shared data and these threads can access the data at the same time, and it's like basically the result depends on who runs first, who runs last. It depends on who runs precisely when, actually. That's why we have a critical region, and if you don't use any method to achieve mutual exclusion, then we have a race condition. There are several methods to avoid race conditions, and one of them is mutexes. Let's explore more. First of all, what are the mutexes? A mutual exclusion object is a program object that allows multiple program threads to share the same resource, such as file access, but not simultaneously. Basically, they are semaphores, but they have just two values, 1 and 0. One is for locking, one is for unlocking. When we entering the critical region, we need to lock the mutex. When we exiting the critical region, we need to unlock the mutex. Let's move on. And here is a TSL instruction for mutexes. You can just see how it works in TSL instructions. And here we have an example with mutexes. As you can see here, we are initializing some variable first, we are initializing the threads, and we are initializing the mutex. After that, we are starting to create the threads, and they will all call the same function, mutex testing. What mutex testing do? Mutex testing basically, just forget the mutex first. It's gonna increment the count. It will say my ID is this and the counter is that. If we don't use mutexes, the threads can try to increment the count at the same time, and they are not capable of incrementing counter at the same time. That's why at the end of the program, the counter might not be 15. It can be 10, it can be less than 10. So we need to use mutex to achieve our goal. If we use lock, we will be sure that there will be only one thread here, and counter will increment perfectly. And the output will be like this, for example. This can be changed. Counter will be same. Always counter will be same by using mutexes. What can it be changed? The order of thread can be changed. Why? Because we cannot know that which thread will start, which thread actually enters this critical region with the mutexes. We don't know. So this can be thread 1 counters, thread 2 counters, thread 3 counters, or vice versa. It depends on your machine, basically. It's actually in 3 minutes. How can I say about mutexes? You can explore more. I hope you enjoyed the video, and here the references I used. Be sure to hit the subscribe button and be sure to like as well. See you in next videos. Goodbye.